So I have here the guide on how to identify different types of conic sections. And this guide is very easy and comprehensive for you to find out what the equation is, if it is a circle, a parabola, an ellipse, or hyperbola. So again, we have four types of conic sections, namely circle, parabola, ellipse, and hyperbola. So this is our guide. So we have here different questions. The first question is, are both variables squared? So if you're given an equation, you ask yourself, are both variables squared? Is x squared? Is y squared? Then if your answer is yes, then you have to ask yourself another question. But if your answer is no, therefore it is a parabola. Again, are both variables squared? If it is not squared, therefore it is a parabola. If it's squared, therefore you need to ask yourself another question. And that question is, do the squared term have opposite signs? Do the squared term have opposite signs? If one is positive and the other is negative, for example, we have x squared and it contains negative y squared. Therefore, if the answer is yes, it is hyperbola. Again, if the squared terms have opposite signs, therefore, it is hyperbola. If your answer to the question, do the squared term have opposite signs, is no, therefore, you need to ask another question. And that question is, are the squared terms multiplied by the same number? Okay, so if your answer for this question is no, therefore, they are both positive. So this is now the question. Are the squared terms multiplied by the same number? Yes or no? If yes, therefore it is a circle. If it is not multiplied by the same number, therefore it is an ellipse. Again, these are the guide questions. So the first question is, are both variables squared? If yes, you need to ask yourself again a question. If no, the answer is a parabola because the equation of the parabola only contains one variable being squared. And for the question, if your answer is yes, the question is, do the squared terms have opposite sign? If yes, if they have opposite sign, one variable, for example, one variable is positive, that is x squared, one variable is negative, that is negative y squared. Therefore, if it is yes, it is hyperbola. If it is not, therefore, you need to ask yourself again another question is, are the squared terms multiplied by the same number? If the positive squared terms are multiplied by the same number, therefore it is a circle. If your answer is no, it is an ellipse because the coefficients of the variables of an ellipse should not be the same. For the circle, it should always be the same numerical coefficient for x squared and y squared. So let us now try to apply what we have learned from this guide. Again, for parabola, only one variable is being squared. For the circle, they have both variable are being squared and then it is multiplied by the same number. For the ellipse, both variable are being squared, but they are not multiplied by the same number. And for the hyperbola, both variable again is being squared, but the variable contains different signs or opposite signs. If one is positive, the other is negative. So let us now try to apply these guide questions. Example number 1, we have 3x squared plus 3y squared minus 6x plus 9y minus 14 is equal to 0. So these are general equations of the conic sections. Again, for number 1, we have 3x squared plus 3y squared minus 6x plus 9y minus 14 is equal to 0. Are both variables squared? Yes. Okay, so if yes, let's continue again with the second question. Do the squared term have opposite sign? Do they have opposite sign? No, because they are both positive. So, are the squared terms multiplied by the same number? Yes or no? Yes, they are multiplied by the same number and that is 3. Therefore, what is the answer? It is a circle. Therefore, this is a circle. Okay, for the second one, we are given 6x squared plus 12x minus y plus 15 is equal to 0. Are both variables squared? Yes or no? No, because only x is being squared. We only have x squared. If the answer is no, therefore this is exactly a parabola. For the third one, x squared plus 2y squared plus 4x plus 2y minus 27 is equal to 0. Let us go back to our guide question. Are both variables squared? Yes, we have x squared and 2y squared. Do the squared term have opposite signs? No, because they are both positives. Okay? Are the squared terms multiplied by the same number? This is x squared and this is 2y squared. Therefore, they are not multiplied by the same number. And if they are not multiplied by the same number, it is now an ellipse. Very good. It is an ellipse. For the fourth one, we are given x squared minus y squared plus 3x minus 2y minus 43 is equal to 0. Let's go back to our guide questions. Are both variables squared? Yes. Do the squared term have opposite signs? Yes, because one is positive and the other is negative. Therefore, if the answer is yes, it is now a hyperbola. Okay? It is hyperbola. For the fifth question, 9x squared minus 4y squared minus 54x plus 32y minus 19 is equal to 0. Let's go back to our guide questions. Are both variables squared? Yes. Both variables are squared. We have x squared and y squared. Do the squared term have opposite signs? This is positive 9x squared. This is negative 4y squared. Therefore, yes, it is confirmed that they have opposite signs. And when they have opposite signs, therefore, this conic section is, yes, it is hyperbola. Okay? And for the last one, so let us now identify the type of conic section for the last example. For the last example, this is 2x squared plus 3y squared minus 8x plus 6y plus 5 is equal to 0. Again, let's go back to our guide questions. Are both variables squared? We have 2x squared plus 3y squared. Yes, they are both squared. Do the squared terms have opposite signs? Okay, this is positive 2x squared. This is positive 3y squared. No, they do not have opposite signs. So are the squared terms multiplied by the same number? This is 2, this is 3. Therefore, they are not multiplied by the same number. And if they're not multiplied by the same number, therefore that conic section is an, yes, that is an ellipse. Okay? So this is how we identify the type of a conic section. Again, we have 4 types of conic section, namely circle, parabola, ellipse, and hyperbola. And this will be our guide questions in which we could identify the type of conic section. The first question is, are both variables squared? If yes, ask yourself again, do the squared terms have opposite sign? If yes, that is hyperbola. If not, therefore, you need to answer the following question. Are the squared terms multiplied by the same number? If yes, it is a circle. If no, therefore it is an ellipse. So are both variables squared? If your answer for this one is no, that is a parabola. Okay, I hope you've learned something from this video lesson. And if you have questions, comments, suggestions regarding this subject, which is identifying the type of conic sections, please do send me a message on Facebook, on Twitter, or Instagram. Once again, I am Engineer Jad Edward Hernandez, saying that mathematics is always fun. Goodbye and God bless. Hi, judges. Welcome to another segment of Monterey Liwag Memorial High School Senior High School Math TV. And for today, we will be discussing the different degenerate cases of a conic section. So let's start with the first conic section, which is the circle. So when do we know that an equation will yield a circle? Okay, so that is our topic for today. If the given general equation of a circle will give us a graph of a circle. So determining when an equation yields a circle. Let us go back to the general form of the circle, which is x squared plus y squared plus dx. plus EY plus F is equal to 0, remember that the right side is always equal to 0. And if there is a constant number here, all we have to do is to transfer that to the left side. Okay, and that becomes the value of F. D and E are the coefficients of X and Y. So why is it important? Why is D and E important in this equation? Because D and E will define the center of the circle. Again, so if you're given this general form of the circle, this equation, the values of the coefficients of X and Y will play an important role in determining the center of our circle. So we have three that we need to remember. Okay, the first one is the equation really yields an equation of the circle. First one, it is really a circle. Second one, it is a single point. And the third one, it is an empty set. So let us first differentiate one from the other. Okay, the first one, let us first determine whether an equation yields a circle using the center. And the formula for the center of the circle is very simple if we are given the general form. That is just negative d over 2 and negative e over 2. And that is the shortcut on how we could get the value of the center, on how we could locate the center of the given circle. So this is the formula. That is negative d over 2 and negative e over 2. So how do we get that? By just simply substituting the values of the coefficients of x and y to find the center. Okay, this is the radius now for the circle will be this formula. We will be getting the radius using this formula. And this formula is square root of d squared plus e squared minus 4f all over 4. So that is the formula in which we could get the radius. But actually, this is the important value for this one. So I'll be calling that as the discriminant. Okay, so why? Because it will tell us whether the equation becomes a circle, a single point, or an empty set, because that is the numerator. In case that d squared plus e squared minus f is greater than 0, for example, we have 100, 1,000, 1 million, it is greater than 0. Therefore, we could finally say that our equation is really a circle. Again, if d squared plus e squared minus 4f is greater than 0, based on the given equation, therefore, we could finally say that our equation really yields a circle. Okay, for the next degenerate case, for the degenerate case, we have a single point. How do we know if an equation of a circle like this will have a degenerate case such as single point? Okay, again, if we have single point, therefore, that single point will now contain the center, assumed to be the center of the circle. So the formula is the same for the center of the real circle. So that is negative d over 2 and negative e over 2. So how do we know if it is a single point? Remember that if an equation of the circle is equal to 0, or the right side, or the radius is equal to 0, if you have computed for the radius which is equal to 0, therefore, it becomes a single point. If d squared plus e squared minus 4f becomes 0, therefore it is a degenerate case of the circle and it becomes a single point. And for the last degenerate case, we'll be having the empty set. So how do we get if the given is just an empty set? By just using again d squared plus e squared minus 4f. So if the computed value for d squared minus e squared minus 4f is less than 0, or the value that you got is negative, or the r that you got is negative, therefore, we will be calling this as an empty set. That is the degenerate case of a circle. So it will be a single point or an empty set, or really a circle. Okay, so in order to illustrate this, given this these ideas regarding the degenerate cases of the circle and determining whether the circle yields whether the equation yields a circle. Therefore, we'll now be applying what we have learned from this one. Again, circle if the discriminant is greater than 0. Single point if the discriminant is equal to 0. Empty set if the discriminant is less than 0 or if it is negative. So let us now try to solve for these examples. We have x squared plus y squared plus 4x minus 10y minus 20 is equal to 0. Okay, so let us first locate the center. So the center is located at negative d over 2 and negative e over 2. Therefore, this becomes our d is equal to 4, our e is equal to negative 10, and our f is equal to negative 20 for this one. Since the constant is now on the left side, and it is not on the right side, since this is equal to 0, therefore, that is now the value of f. Okay, so substituting the values of d and e to the center, therefore, this becomes negative d over 4, that is negative 4, negative d over 2, negative 4 over 2, negative e over 2, that is negative of negative 10 over 2. Therefore, the center now is located at negative 4 over 2, which is negative 2. Negative of negative 10, that is positive 10 over 2. Therefore, the center is located at negative 2, positive 5. So this is the center. So we'll let us now determine whether this center is really the center of the circle or is it just a single point. Okay, by using the discriminant, let us now get the discriminant. Later, we'll get the radius. For the discriminant, that is d squared plus e squared minus 4f. Okay, so using d squared plus e squared minus 4f, therefore, we'll be having 4 squared plus our e is negative 10 squared. 4f, that is negative 4 times negative 20. Therefore, this is now equal to 16. Negative 10 squared is 100. Negative 4 times negative 20, that is positive 80. 16 plus 100 plus 80 will give us an answer of 196. And 196 is greater than 0. Therefore, we could say that this is really a circle. So for the first example, this is a circle. Okay, and what is the radius of the circle if this is a circle? So the radius is very simple by using the formula. The formula is d squared minus e squared minus 4f all over 4. But since we have computed for this value, and that value is just equal to 196, that is our discriminant, therefore, r now is equal to the square root of 196 over 4. Okay, and the square root of 196 over 4 is just equal to the square root of 49. Therefore, r is equal to 7 units. Okay, so therefore, example number 1 is really a circle. Okay, for the second example, we now have x squared plus 4x plus y squared plus 6y is equal to negative 13. Remember that this is negative 13. Therefore, we need to transpose or transfer negative 13 to the other side. Therefore, this becomes x squared plus 4x plus y squared plus 6y plus 13. Okay? So, the center now is located at negative d over 2 and negative e over 2. But what is the value of d? Therefore, d is equal to 4, re is equal to 6, and rf is equal to, since this is negative 13, we transfer that out to the left side, that becomes positive 13. Okay? Therefore, this becomes negative d over 2, that is negative 4 over 2. Negative e over 2, that becomes negative 6 over 2. And the center now is located at negative 4 over 2. Therefore, it becomes negative 2. Negative 6 over 2, that is negative 3. The center is located at negative 2, negative 3. So this is the center for this equation. And for the discriminant, again, we'll be using the formula d squared plus e squared minus 4f. Is it greater than 0? If it is greater than 0, therefore it is a circle. If it is equal to 0, it is a single point. And if it is less than 0, therefore it is an empty set. If it is a single point, therefore that point is just the center. Okay? So let us now try to solve d squared minus e squared. Therefore, that is 4 squared plus e squared, which is 6 squared, minus 4 times 30. 4 squared is 16. 6 squared is 36. Negative 4 times 13 is negative 52. 16 plus 36 is 52. 52 minus 52 is 0. Therefore, our discriminant is 0. And if that is 0, therefore we could say that this is a single point. So it is just a single point. Again, this is just a single point. And what is that point? That point is supposed to be the one that we have computed for the center, and that is -2, -3. This is the answer. It is a single point. Again, if you're able to get the value of r, which is equal to 0, or r squared, which is equal to 0. Therefore, it is a single point, and that point is just the value you have computed for the center. Okay, so let us now try the third example. So we have x squared plus 10x plus y squared plus 8y plus 50 is equal to 0. Okay, so let us try to get the value of d. D is equal to 10, since that is the coefficient of x. E is equal to 8, since that is the coefficient of y. And f now is the constant. And since we now have the constant on the left side, we'll be having 50 for that one. Center is located at negative d over 2, negative e over 2. Okay? Therefore, this is equal to negative 10 over 2 and negative 8 over 2. And what is negative 10 over 2 and negative 8 over 2? Therefore, that is negative 5, negative 4. So this is now supposed to be the center if it yields a circle, but let us now find out if it is really a circle using the discriminant d squared plus e squared minus 4f. Okay? So we'll be having 10 squared plus 8 squared minus 4 times 50. 10 squared is 100, 8 squared is 64, and 4 times 50 is 200. So we'll now be having 164 minus 200, and 164 minus 200 will give us an answer of negative 36. And negative 36 is less than 0. So if the value of the discriminant is less than 0, what can we say? Therefore, if that is negative, we could say that the equation is just an empty set. Therefore, it is an empty set. Okay? So we now have an example. We now have different examples when an equation yields a circle, it yields a single point, or it yields an empty set. Okay, what if we're now given this example? Okay, for the fourth example, we are given 2x squared plus 2y squared minus 12x plus 8y minus 24 is equal to 0. So based on the center, on the formula for the coordinate of the center, we'll be having negative d over 2 and negative e over 2. So this is for the center. Is it still applicable if we have the coefficients of x squared and y squared? Okay, so actually, all we have to do in order for this formula to be applied on this example is to divide all the terms by the coefficients of x squared and y squared. And their coefficients are just the same, that is just 2. Therefore, if we have here 2x squared divided by 2 plus 2y squared divided by 2 plus 12x over 2 plus 8y over 2 minus 24 over 2 is equal to 0. Cancel, cancel, x squared. Cancel, cancel, y squared. Negative 12x over 2, that is negative 6x. Positive 8y over 2, that is positive 4y. Negative 24 over 2, that is negative 12 over 0. So if we have just divided this by 2, then that is just 0. Okay, so we will now be applying this one. But let us first identify the value of d, the value of e, and the value of f. For d, we'll be having the value as negative 6. For e, that is positive 4. And for f, that is negative 12. Okay, so using the discriminant, therefore, that is d squared minus e squared minus 4f. This becomes negative 6 squared minus 4 squared. This should be plus. So this should be plus. So that is plus 4 squared minus 4 times negative 12. This is for the discriminant. How about for the center? Okay, for the center, so let us now try to solve for the center first. So that is negative d. So that is negative 6 over 2. Therefore, that is positive 3. For the y-coordinate, that is negative e over 2. So that is negative 4 over 2. That is negative 2. And the center is located at positive 3 and positive 3, negative 2. Okay, and for the discriminant now, therefore we'll be having negative 6 squared is 36 plus 4 squared is 16. Negative 4 times negative 12 is positive 48. Okay, so let's now try to add 36 plus 16 is 52. 52 plus 48 is 100. Therefore, 100 is greater than 0, and this is a circle. Therefore, we'll now be ready to compute for the value of the radius, and that is d squared plus e squared minus 4f over 4. But since we are done computing the value of the discriminant d squared plus e squared minus 4f, so let us just try to substitute that on our equation. And that becomes, what is d squared plus e squared minus 4f? That is 100. Therefore, it is equal to square root of 100 over 4. And the square root of 100 over 4 is just equal to the square root of 25. Therefore, r is equal to 5 units. Okay, so that is how we solve for the center and the radius of this one. Therefore, it is not a degenerate case. Therefore, this equation really yields an equation of the circle. And this is, if we graph this, therefore, it contains the center and the radius, and it is really a circle. Okay, so that is how we determine when an equation yields a circle. So I hope you have learned something from this video tutorial or video lesson. Again, for the equation of the circle, it may be a circle, it may be a single point, or an empty set. The degenerate case would be a single point and an empty set. Always remember that for the circle to become a circle, the discriminant d squared plus e squared minus 4f should be greater than 0. If it is a single point, therefore that should be equal to, is greater than, for this one, this should be greater than 0 if it is a circle. And if it is a single point, that is equal to 0. And if it is an empty set, that becomes negative or less than 0. So if you have questions, comments, suggestions, do not hesitate to message me on Facebook, Twitter, and on Instagram. Once again, I am Engineer Jod Edward Hernandez saying that mathematics is always fun. Goodbye and God bless.